Hello guys, welcome back to the channel Mathemagix JEE. Welcome guys. In this session we have a problem from ISI entrance 2014. In this problem we have to find the minimum value of this modulus, which is involving all the six trigonometric ratios. This problem may look very easy and very simple. Some of you may think that okay, let us take x in the first quadrant so that all these trigonometric ratios become positive. That means we can take this cases this sine x plus cosecant x, right? These are reciprocals of each other. This is greater than equal to 2, right? Then we have cos plus sec greater than equal to 2, and then tan plus cot greater than equal to 2 by the AMGM inequality, right? And you may think that if these terms are greater than equal to 2, that means their sum must be greater than equal to 6. And the minimum value of this modulus expression, the modulus basically opens with positive sign because all the terms here are positive when x is in the first quadrant. You may think that the minimum value will be option D, 6, and this will be totally wrong. In this session we are going to discuss why this approach is wrong, and we will also discuss how to solve this problem correctly. Okay, so let us start our discussion. Okay, so let us discuss why our previous approach was wrong. When we were applying the AMGM inequality on these terms, we should remember that this equality case, that sin x plus cosec x greater than equal to 2, right? This equality case we are talking, that sin x plus cosecant x equal to 2, then tan x plus cot x equal to 2, right? So we are talking about equality cases. Let's take these cases. So cos x plus sec x equal to 2, then we have tan x plus cot x equal to 2, right? All these three equalities must hold true so that the minimum value is equal to 6, right? But think about this. If we have sin x plus cosec x equal to 2, we must have sin x equal to 1 and cosec x equal to 1, right? But that case is not possible. Why? Because if sin x is 1, x may be pi by 2 or it may be 5 pi by 2, right? But in that case, this secant x is not defined, right? So the points x equal to pi by 2, x equal to 5 pi by 2, and so on, these points are not even in the domain of this function. Similarly, you can find that if we take the case cos x plus sec x equal to 2 and we take cos x equal to 1, that means x equal to 0 or x equal to 2 pi, these points are not even in the domain of this function. Why? Because we have this cosecant x, right? The domain of cosecant x excludes all the point x equal to n pi, where n is an integer, right? So these points are already excluded from the domain. That means we cannot count them. So these equalities cannot hold true simultaneously. This you need to understand. That's why our approach was wrong. Now what will be our correct approach for this problem? We have to solve this using the calculus. Okay. So let us first assume this inside this modulus function to be some function of x. Okay, fx equal to sin x plus this will be cos x plus tan x plus here if we take cot x, okay, with tan x, because ultimately we will be decomposing this tan x, cot x, cosecant x and sec x in sine and cosine function, okay, so that our function is represented in terms of sine and cosine only. So we have this cosecant x plus secant x, right? So if we decompose this trigonometric ratios in terms of sine and cosine, we will get sin x plus cos x plus this will be sin square x plus cos square x divided by sin x cos x, right? So this will be 1 divided by sin x cos x plus this will be 1 by sin plus 1 by cos, that means sin plus cos divided by sin cos, right? So this will be sin x plus cos x divided by sin x cos x. Okay. So now see a very interesting thing, that this quantity sin x cos x we can represent in terms of this sin x plus cos x. Why? Because let's say if we take this popular identity that sine 2x equal to sine x plus cos x whole square minus 1, right? This is a standard identity. We know this identity comes in use in the chapter of integration, where we have to substitute this sine plus cos equal to some variable, right? T, let's say. So in this case, we have sine 2x equal to 2 sine x cos x. That means we can write this sine x cos x in terms of this sine plus cos, right? So that will be our approach. We have to convert this function f of x into some function of a new variable, which is t. And t is what? T will be our sine x plus cos x. So let's assume this variable to be some t. Okay. So this will be some g of t, this new function. Okay. This will be t plus 1 by, this will be t square minus 1 by 2, right? So this will be 2 plus this will be t divided by t square minus 1 divided by 2. That means t plus this will be 2 into 1 plus t divided by t square minus 1. Now note that this t square minus 1 cannot be 0, because if t square minus 1 is 0, that means sine 2x is 0, and sine 2x cannot be 0, as we already discussed that sine 2x equal to 0 means sine x cos x equal to 0. That means either sine x equal to 0 or cos x equal to 0, but that case is not possible. If sine x equal to 0, x should be equal to some integral multiple of pi, but those points are not in the domain of this function, right? So the domain here I am writing, the domain here, x is not equal to some integral multiple of pi by 2, right? Because k into pi is nothing but some k dash into pi by 2, right? Integral even multiple of pi by 2, and we don't have also the odd multiples of pi by 2 because of this secant x function. That means we don't have the integer multiples of pi by 2 in our domain. That means this t square minus 1 is non-zero, as well as we can see t plus 1 is non-zero, right? So we can cancel this factor here. We can write this as t plus 2 divided by t minus 1. Okay. So our g of t becomes t plus 2 divided by t minus 1, where t belongs to what? T belongs to the range minus root 2 to root 2. Minus, why this range? Because as we discussed, sin x plus cos x equal to some t, right? And the range of sin x plus cos x is already known to us, which is equal to minus root 2 to root 2, closed. Okay. But we have to exclude these points t equal to plus minus 1, because we are saying that t square minus 1 is non-zero, right? So we have this function here. Now we have to minimize the function h of t. Let's say h of t is mod of gt. So we have to find the minimum value of this function. Okay. Now this function will be simply, if we write the definition, g of t if g of t is greater than 0, right? So we can check the sign of this gt here. Let's check. Gt becomes t square minus t plus 2 divided by t minus 1, right? So the numerator is positive. You can see this is a quadratic function with d less than 0 and a positive, so this will be always positive, right? So the sign of gt actually depends on the denominator. So we can see if t is less than 1, this will be negative, right? So the mod will open with negative sign, and when t is greater than 1, we have this function equal to gt. So let us find the minimum value of this function h of t. Okay. So h dash t, if we try to find, it will be minus g dash t if t less than 1, and g dash of t if t is greater than 1. So g dash t will be what? G dash t, if we calculate, it will be 1 minus 2 divided by t minus 1 whole square, right? So g dash t equal to 0 gives us two critical points. T minus 1 is equal to plus minus root 2. T minus 1 whole square equal to 2. That means t minus 1 is plus minus root 2, right? So t minus 1 equal to plus minus root 2. So we have the critical point t equal to 1 plus root 2 or 1 minus root 2. Okay, so 1 plus root 2 will lie in this range, right? T is greater than 1, and t equal to 1 minus root 2 will lie in this range. So let us find the values of h of t at these points. So at t equal to 1 plus root 2, we have the value equal to this definition. So this will be simply g of t, that means 1 plus root 2 plus 2 divided by root 2, right? So this will be 2 root 2 plus 1, and this h of 1 minus root 2, if we calculate, this will be minus g of 1 minus root 2, right? Because t is less than 1. So if we calculate, this will be minus outside, then 1 minus root 2 plus this will be 2 by minus root 2, that means minus root 2, right? So this will be 2 root 2 minus 1. That means our minimum value of this function comes out to be 2 root 2 minus 1. This will be our correct answer. So option B will be our correct option in this case, right? So we saw how this problem should not be done using AM and GM inequality, and we also discussed why that approach is wrong. Okay, I hope you understood the concept behind this problem. How did we substitute this sine plus cos equal to some new variable, and then we applied the concepts of calculus to find the minimum value of mod of gt. Okay.